Okay. What? Nice. Hello, everyone. I'm Jean. I'm a firmware application engineer at Ledger. I've been working there for the last 4 years. And I'm very happy to be here today to talk a little bit about recent work that we've done around improving the situation of smart contract interactions using Ledger Nanos. So just a little bit of context for those who are not familiar with our platform. So at Ledger, we are building secure hardware. So this is buttons, a screen, and a secure element that is connecting these elements. And on top of it is running our in-house operating system. It's called Bolos. And it's a programmable SDK. So there's an open SDK. You can create new applications on it. So most applications actually are written by third parties. And some of these applications are built by ourselves, so such as the Bitcoin application and, of course, the Ethereum app. But with secure hardware, it doesn't work alone, of course. There's a companion app that we call Ledger Live, and it provides a rich interface to create accounts on blockchains and receive funds, send some money, and recently we added also swap functionalities. If you're new to this space, you might wonder, why should you use a hardware wallet rather than using just a regular software wallet? Well, there's one very obvious reason, is that you just don't want to have your private keys on your computer, because it's much easier to hack a computer or a mobile than to hack into a dedicated hardware wallet that has this sole purpose, and that is banking-grade security. Also, it provides you, one of the pillars of the security of hardware wallet is to provide you with information on screen. So we have a philosophy which is called, what you see is what you sign. So here is a very basic flow for a simple Ethereum transaction. So you see that you will have displayed the amount that you are sending, then the destination address and the maximum fees, and then you have the choice to either accept or reject the transaction. So you always have this information, and this is a guarantee, so this is a secure flow. However, what I'm going to talk about today is about an issue that we have in some cases. And if you are a Ledger user and a DeFi user or dApp user, you've probably already encountered this issue. It's called the blind signature issue. So let's take an example transaction, like lending some assets on Compound, for instance. If you, in the ideal world, you will have the right flow on the green side, sorry, where you have a detailed explanations of the transactions that you are currently signing. So you see, oh, I'm lending some assets. This is the amount of USDT that I am lending, and I am talking to the Compound USDT contract. Okay, this is a secure signature. I can approve. But actually, in 99% of the cases, you fall into the orange flow on the left, which is not secure at all. And this is blind signature because, as you can see, there's not much information displayed on device. You just have this screen, data present. Okay, it's not much info. So this is pretty bad, and I'm going to illustrate how you can exploit this. So let's say you are on Curve, for instance, and you want to claim some rewards. You're going to click on the claim button, of course, and it's an on-chain event, so you get a pop-up from Metamask telling you to sign this transaction. And in this case, well, bad luck, your computer is compromised by a remote hacker. And what the guy has done is that he has replaced the Metamask extension with a slightly modified one, which has the ability to replace on the fly the transactions. So instead of signing a regular claiming transaction from Curve, you are going to sign the hacker transaction that will move your funds. So Metamask will show you just the regular screen that it always shows, and you will click on confirm, and then your imposter transaction is sent to your device, and you will get an approval flow that doesn't give you much information. And as you always get this kind of information, well, you are not surprised because you see it every day, and you're just going to accept it, and oh no, your funds are gone. You might think this is a theoretical attack, it only happens to others, and it's a rare thing, it's not common. But it's not. Meet Hugh Karp. So this guy, it's a founder of Nexus Mutual, which is an insurance fund for DeFi. And last year, well, he lost $8 million just with the scenarios that I described before. So it was pretty bad. Like he was using the industry best practice, like having a hardware wallet dedicated to managing his private keys, and yet he lost money. So this is pretty bad for us hardware wallet vendors. Like it's hard to react to this, to give the proper answer, because it's a hard problem to solve. Actually, there is a feature embedded in our devices that allows to have a deeper look into what you are signing. So you can go into the settings of your Ethereum app on your Nano, and you will see that there's an option called Enable Contract Data Debug. So debug is in the name, so maybe that's not something we want to push our users to use. And it will display information contained in the transaction. So here you see the selector, so it's method ID, it's 4 bytes, and it shows it is bound to method name of the smart contract you are interacting with, and then it will show all the contract data, 32 bytes by 32 bytes. I speak hexadecimal, I don't know for you guys, I don't know for your grandma or friends, probably they don't. And even if I speak it, I don't know by heart the selector and the order of the arguments of every method in the smart contracts I interact with. So even though this exists, we can't advise people to use it. So at this point, well, the situation is pretty bad. We have identified a problem, and there's no easy solution to fix it. The Nano application is not able to parse contracts, and there's thousands of contracts, so there's a lot of work to fix it. And we want to do it, but when the Nexus Mutual hack happens, well, we make an assessment of what it will cost us to build a solution for this issue, and as always, the roadmaps of every team are full, and it's going to take some time. But actually, we've been lucky, because there was a big project at Ledger that was being built, and we realized that one of the hard requirements of shipping this project was to actually fix the solution, the issue of blind signatures. So let me present you this new shiny big project. It's called Ledger Live App Catalog. And remember Ledger Live? I talked about it before, the companion app for our devices. Well, we are turning it into a full-fledged dApp browser. So now every dApp can be accessed directly from Ledger Live, rather than going into a browser and access it through Metamask, even if your keys are in a Nano device. So we are integrating more and more dApps into this. It's very fresh. There's many advantage to move to this solution. Like for Ledger users, it's very nice because they stay in control. They can explore the boundaries of DeFi from within an environment that they already know. And they don't have to install third-party extensions and things like this. For developers, it's also very nice because there's not much work to do to integrate into this project. We are basically linking an iframe to the front end of your dApp and then injecting our own custom Web3 provider in it. So it's a pretty easy thing. And it allows you to access to a large, fully converted crypto user base. So all the Ledger users, we sold like 3 million units, I think, worldwide. And these are people that are not necessarily using DeFi, but they know what is crypto and how to use it. So it's nice to access them directly from Ledger Live. And of course, for Ledger, it's great because it removes our reliance on third-party providers to access Web3 services. So we can push updates much faster than before, and yeah, this is great for us. But how does this relate to the issue I mentioned earlier, like the blind signature issue? Well, that's easy. It's just that we have a philosophy in Ledger Live. It's that what you see on Ledger Live, you must be able to check it on your device. So this is just what you see is what you sign, both on laptop and mobile and device. So if we want to have that and integrate dApps in Ledger Live, then it means that the device must be able to parse smart contract transactions. So now we had to fix it, and we got resources to fix it, and we got push to fix it, so we fixed it. So how did we do it? Well, a natural solution, if you want to fix this issue of parsing, would be, if you're familiar with Solidity, would be to use ABIs. So these are big JSON files, big descriptor of the interfaces of smart contracts. So for instance, it gives you information about the name of methods, the name of method arguments, and the type of these arguments. And if you combine this with a raw Ethereum transaction, then you are able to extract the useful values and eventually display them on device. But there are issues proceeding this way. The first one is the size of ABIs, because they are huge files, and we have a very tiny target. So let me present you the Nano S. It's just 10 kilobytes of RAM, 28 megahertz, and 320 kilobytes of flash, single-threaded. It's very squishy. But even if we manage to compress smart contract ABIs to make them fit in this tiny chip, this would not be ideal either. There would be a second issue, because this would allow us to build a generic smart contract parser. But actually, when you investigate some of the methods to support in smart contracts, you will see that there are some parameters that you really don't care about and that you don't want to parse and you don't want to display. I will take an example. In Paraswap, which is one of the first dApps that we support in the Nano devices, the swap method takes a lot of arguments that are totally useless for the users. They are not security sensitive, and we don't want to parse them. There are some that are very important, like what is the token that you are swapping, what is the amount that you are swapping, what is the token that you are receiving. This is important. But then you have all the routes, custom structures that indicate to the smart contract where should the money be swapped, like on Uniswap, on Curve, whatever. If we were to build a generic parser, we would have to display this information as well, and we would end up. Hey. Hello? Yay. Where was I? Yeah. So you don't want to display all this information to the device, to the user, sorry, on the device, because then you end up with dozens of screens with useless information, and we know our users, and they are just going to do click right, click right, click right until the end, and not check any information on the device, and just approve, and we fall into the case we had before. People are doing blind signature. So this is not good. So instead of a generic parser, we will have to write some custom logic, custom parsing for every dApp. Is it difficult? Well, actually, not that much. So this is a raw Ethereum transaction for the case I was talking about before, like a compound lending transaction. And what is colored is the useful information that we need to parse to display to the user. So in the blue, you have the contract address, of course. So we get this, and we check that it's compound. Then the method selector, so 4 bytes, it's always 4 bytes, so it's easy. And it's unique to the method. And then the arguments of the method, so here 32 bytes for an amount, because Ethereum EVM only has 32 bytes elements. Yay! So you see, it's only 3 elements to extract from the transaction. So it should be easy to write some custom logic to extract that and parse it and display it to the user. So where do we put this custom logic? Well, we had multiple iterations. At first, we did the easiest one, which was to directly edit the transaction parser within the Ethereum app to add this custom logic. But this was really bad for at least 2 reasons. The first one is that the Ethereum app repository is pretty sensitive, and we really don't want people to do dangerous things in it by contributing to it. We are talking about hundreds or thousands of dApps. We don't want people to mess with our repository. And even more with the transaction parser, it's very, very sensitive piece of code, so adding custom logic there is really bad. Also, we have an issue with size, because if we want to support many dApps, then it means adding a lot of custom logic to the Ethereum app, and it grows bigger and bigger and bigger, and then it doesn't fit in our tiny chip. So this was bad. We switched to another model, which was a little more work. We re-architectured the transaction parser so that it becomes hookable by external logic. So this external logic then got a name. We called it a plugin. And so we had the compound plugin, and it's fairly simple. The Ethereum app gets a raw transaction to parse. It starts parsing it, and at several steps, it will call the custom logic and hand him the things that it's just parsed, so that you can do some custom logic on it and create useful strings for the user, for instance. So this was a good improvement, but it was not enough. It was better because then developers don't have to mess with the transaction parser, which is the most sensitive part of the code. But still you have the issue of the Ethereum app growing bigger and bigger and not fitting into the tiny chip anymore. If you have hundreds of plugins, it just doesn't fit. So we moved to something even better, which is the external plugin. So this time it's exactly the same as previously, except that we move the plugin out. It becomes its own application, actually. So there's a downside. The user has to install another app, but it's a very small app. And this app talks with the Ethereum app. So let's see into details how this works. Oh, yeah, first, so this is solving the 2 issues we had before, because you only install the plugins that you want, so it's not going to take space on your device. Like if you're not a compound user, you don't install the compound plugin, and then you have space to install other apps. It's fine. You only install the plugins for the dApps that you actually use, And as it's out of the Ethereum app, then it's very easy to contribute as a third-party developers, because you can just create your repo, and then it's not bound to the Ethereum app, so you don't need QA and security reviews from Ledger. I mean, we are going to review that your plugin is not a Trojan, but that's it. We don't have to check that it doesn't break Ethereum. So now in details, so this slide is way too complicated. I made it for a blog post and didn't got time to make it again. Sorry, I will go fast over it. This is just to talk about how the Ethereum app is talking with the Compound plugin or any plugin. So we have the Bolos operating system, which provides a syscall to jump from one app to the other and save the context of the caller, so we can come back to it later. And this is how the transaction parser inside the Ethereum app is going to send some of its unparsed data to the plugin. The plugin, with its custom logic, is going to parse it and do something useful with it, and then return useful strings that the Ethereum application is going to display to the user in the approval flow. Yeah, so that's it. But now you understand that, well, there's going to be a lot of plugins, so this talk is actually a call to action in disguise. We are going to write some plugins, but I need every dApp developer out there to write its own plugin for our platform. It's C code. So it's actually not so much work. The plugins are very small. Like for instance, this is the main file. Even if you don't know C, it's not so hard. So this is for the Lido plugin. First, we hardcode the selectors that we want to support, so the methods to support. Here for Lido, it's very easy because there's just 3. So staking, wrapping the token, and unwrapping it. And then you have a standard function, so dispatch plugin call, the second one. And here you have all the hooks. So they are declared, but they are not defined. And these are the hooks that are called by the transaction parser, basically. So these are the functions that you have to define as a plugin developer. And here you will do very basic operations like, oh, I'm getting a 32 bytes element, and I know this is an amount. I'm going to turn it into decimal and add a token ticker next to it and return that. Basically, that's the work to do. But we didn't find a way to automatize it, so we need humans to write this code. Plugins are small, like really small. So you see for Lido Compound, it's like 1,500 lines of code. And we have a boilerplate plugin, so you don't start from scratch, you start from this boilerplate. And it's already like 1,000 lines of code, so actually the custom code to write is really small. And it ends up in very small binary sizes. Like the Lido app is much, much smaller than the Ethereum app, for instance. Some plugins are harder to write. For Paraswap, it was a little harder because there's a lot of function to support and they have custom solidity structure, so it was a little more work, but it's really feasible. So yeah, thanks for listening to me. Here are resources to start building. Keep doing great dApps, and please start writing plugins. Please clone the app plugin boilerplate repository. You don't even need a hardware wallet you don't need a Nano S to program. We have an emulator called Speculoos. It's working great. Also, we're here to help. We have a developer Slack, and we are working on a step-by-step tutorial to create your plugins. So it's coming soon. Thank you.
Thank you for your talk. My question would be, so you mentioned that you're using your own Web3 provider. Yeah, basically, can I hook this Ledger Live app to my own RPC endpoint, or do I have to use yours and trust you? And I care about privacy and trustless setup, so whether it would be possible with this.
Maybe someone in the room can answer to this question better than me, because I'm on the embedded side. So.
So can I connect Ledger Live to my own node, basically, to my own RPC?
So currently we have multiple ways to handle RPC. We of course have Ledger internal RPC nodes, but if you plan to use the app through Ledger Live, actually it's going to go currently through Alchemist RPC. There is no way to use your own, but actually it could be quite easy to do. Not having about it, so yeah, that's definitely a possibility. If you want to use your own node, that's possible. That's a feature that could happen in the following months, yeah? You're welcome.
Thank you for this talk. I have two questions. First, on the Ledger Live app, why is it not another Chrome plugin also? Because also maybe I want to use my browser because I can have other additional tools on it. So why this approach of having a separate app and not the other way around? And the second one is, how do you trust on the Ethereum app in the Ledger what's happening from the plugin? Is it do you double check everything, or you just take parameters from the external plugin? Is there a reasoning on how you can trust what's happening in this code?
So I'll answer the second question first. As we as Ledger are reviewing and signing the plugins, there is no security issue because we know what the code is doing. So the Ethereum app is transmitting information to the plugin, and it has an internal check to know if it is the right plugin to call from the content of the transaction, actually. So it just works this way. I hope I answered the question. Okay. And for the second one, well, first, if you had a Ledger a long time ago, we had Chrome apps. There was no Ledger Live, and it was pretty bad. We were dependent on Google Chrome. And we don't really want to be dependent from Google Chrome, so I guess this is part of the answer. So we built our own native application, and actually, like, our competitors are also moving to this approach. Like, for instance, Trezor is releasing the Trezor suite, I think, and it's also an independent application. It's just we have more capabilities. It's easier also to communicate with the device through USB, because you have like regular USB HID rather than using weird things from the browser. When we released Ledger Live, there was no easy way to talk from the browser to a device. We had to use a weird hack using U2F as a transport layer, which is broken now, by the way. So I guess, yes, it's both. It's a very historical answer that I'm giving to you. Yep.
Hello. As I understand, a plugin is a kind of application in the Ledger. But on a Ledger S, Nano S, you have only 4 applications allowed. So it takes, so your Ethereum application, you will take, in fact, 2 application slots, and you'll be left with 3 other. Is that right?
It's not. So we say to customers, yeah, you can install 4 apps, because if you install the 4 biggest apps, they fit in the device, and you can fit another one. But actually, not all apps are equal. There are some small ones, big ones. And you are not limited in the in the quantity of applications to install. Like some are really tiny, and plugins are such tiny apps, so you can probably install like 15 of them on a Nano S with the Ethereum app. So it's something. It's better than 4. And on Nano X, you have room for much more than that because it's a beefier version of Nano S. There's like 1.2 megabytes of flash instead of 320 kilobytes on Nano S. Okay. Well, thank you guys.